Hi, and welcome to the next video in the mathematical logic sequence talking about propositional logic and truth value assignments. This video is just a demo, really just like a code, sort of like minimal sort of like simulation kind of demonstration of the idea of a truth value assignment. I don't really know how valuable this sort of thing is, but I thought it would just be kind of neat to maybe just simulate something like what we're talking about in some code. Maybe just some people find that sort of explanatory and interesting. So we'll see if this is of any use. But in any case, so I'm basically just going to make a little tiny piece of software that simulates truth value assignments. So the way that I'm simulating this in Python is I have this this variable phi that is storing a list, and the list, it's effectively an expression, right? It's just like an expression. What is an expression? An expression is a sequence of symbols in the language. And I'm simulating kind of the symbols in the language by these strings that have and, P1, not P2. So this is my simulation of the expression that ultimately we hope to parse as the sentence, which is primarily a conjunction. The left conjunct is P1, supposed to be read, of course, as P sub 1. The right conjunct is a negation sentence, namely negation P2. Okay, so that's what phi is. Psi here is some other sentence, just to give another example sentence. And I'm going to have a truth value assignment, which is going to be a kind of positionally determined assignment of truth values to the two atomic sentences P1 and P2. So because the first coordinate of this truth value assignment is true, then P1 in this truth value assignment is assigned the value true. I could change that, of course, to any truth value assignment I want. But so in this particular simulation, I'm having the truth value assignment for P1 is true, and also P2 is true because the second coordinate is also true. And then down here, I'm not going to, necessarily explain all of this source code too much, although, you're free to look at it and understand what I'm doing here. This is a certain amount of just parsing right here. So basically, given a sentence I want to find, or given an expression, I want to find the first sub-sentence starting from the first character in the expression. I want to find the end place where, I most nearly can interpret it as a sentence. It's just necessary for some of the later parsing that goes on in here. I build a sort of class, an object meant to represent a sentence. So you will primarily, well, really only, input an expression called P, and this will sort of do the job of figuring out what kind of a sentence is it. Is it an atomic sentence? Is it a negation? Or is it a binary connective? If it has a connective, which one is its main connective, which would just be the very leftmost symbol in the expression, and then to parse the first sub-sentence. So if it's an atomic sentence, there will be no connective at all. If it is a negation, it'll have a not as its main connective and then only one sub-sentence. And if it's a binary connective, it'll have some binary connective symbol. That'll be the main connective. It'll have a left sub-sentence and a right sub-sentence, which I'm calling here subsent 1, subsent 2. So anyway, that's just a sort of basic representation of sentence objects, and you input an expression and it parses it into these sub-sentences. So what I had as an expression earlier called phi, I'm now turning into a sentence called phi. So basically giving it structure, the structure of a sentence, basically. And then with that structure, I am now in a position to be able to evaluate the sentence using the truth value assignment. So here I'm just defining a function so that I can input any sentence in any truth value assignment. Of course, eventually I'll use the sentences that I've already constructed earlier and the truth value assignment that I defined earlier. But here is the instructions on how to evaluate any given sentence and truth value assignment, P and T. And the code here basically just simulates what the binary connectives, so to speak, mean, or at least the semantics that we've given them, as we talked about when just talking about truth value assignments. Namely, an atomic sentence just has whatever truth value assignment the atomic truth value assignment says. Sorry, and maybe as a point of clarification here, T is actually not a truth value assignment, right? It's an atomic truth value assignment, and the function eval is the extension of that atomic truth value assignment so that it can evaluate any sentence. So in a sense, eval here is the truth value assignment based on the atomic truth value assignment T. Anyway. But the rules here, or the definition of eval, is basically just the semantics that we gave for truth value assignments. So to compute not, you just find the truth value, the evaluation or the truth value assignment for the sub-sentence under the not, and then just flip it. Right? It's basically what you see here if the main connective is a negation. Right? Otherwise, if it's not atomic and it's not a negation, it's got to have two sub-sentences, it's got to be a binary connective, and in each of the different cases of what that binary connective could be, it could either be and or if and only if, and I have some only very slightly clever ways of, right, I mean, and is just obvious, right? It's basically just built right into Python, or is obvious. If you'd have to know that that's equivalent to a disjunction where you negate the left and keep the right, should be familiar from an earlier symbolic logic course. And then the final condition catches the if and only if, right? This is, I'm not doing very much validation of the inputs, but if it is a valid input, then the only binary connectives could be and or if and only if. And so in that final case of an if and only if, it gets caught by the final return value. And that's a slightly clever, very slightly clever way of computing an if and only if. And then we can run the simulation, right? So here I have my inputs. We can run the simulation, and the first sentence comes out as false. And does that make sense? Should it come out false? If our sentence initially was this sentence, where I am taking P1, negation P2, conjoining them, and they're both assigned the value true, should that come out false? Well, negation P2 comes out false because P2 is true. Then I take a true and a false, I conjoin them, and the result should be false, which it came out false. So that seems like things are going well. How about the second sentence, which we saw comes out true? Should it come out true? Well, P1 is true, therefore negation P1 is false. P2 is true, therefore negation P2 is false. So I'm taking an if and only if applied to false and false, so that should come out true, and it does. So there's a little simulation of the things that we've been talking about.